A very good morning to all of you. I'm Faculty of Science at Lotus Petal Foundation, Gurugram. Today we are going to talk about an important topic in physics, that is gravitation. So let's start. Gravitation force of the earth or gravity. A force is necessary to produce motion in a body. A body dropped from a height falls towards the earth. It indicates that the earth exerts a force of attraction on the body. The force with which the earth pulls the objects towards its center is called as the gravitational force or the gravity. Now, this gravitational force of the earth or gravity is responsible for holding the atmosphere above the earth, for rain falling to the earth, for flow of water in the rivers, for keeping us firmly on the earth, for revolution of moon around the earth. The gravitational force between the earth and the moon, it causes the tides in the sea. Think why tides are high during full moon and new moon day. Newton's universal law of gravitation. Every body in the universe attracts every other body with a force which is equal to the product of their masses, and here it is directly proportional to it and inversely proportional to the square of the distance between them. So it is explained in the diagram that there are two objects having the mass m1 and m2 and they are separated by a distance r. So according to Newton's law of gravitation, the force will be directly proportional to m1 into m2 and inversely proportional to the square of distance between them, that is r square. So we have derived an expression for force of gravitation which is equal to capital G, which is referred to as uh, gravitational constant multiplied by mass of the two objects and divided by the square of distance between them. These are the properties of gravitational force: that it is the weakest force in nature, it is attractive in nature, it is central force, it obeys the inverse square law, it is a long range force, and it does not depend on the medium between the interacting bodies. Universal gravitational constant or capital G is equal to the force of gravitation multiplied by square of the distance between the objects divided by the product of their masses. Now the value of this gravitational constant remains constant throughout, and it is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. The value of G does not depend on the medium between the two bodies. It remains constant throughout the universe, and the SI unit of this capital G is Newton meter square per kg square. So we can say universal constant G is numerically equal to the force of gravitation which exists between two bodies of unit mass which are kept at a unit distance from each other. Though the various objects on this earth they attract one another constantly, they do not cause any visible motion because the gravitational force of attraction between them is very small. The gravitational force due to Earth on an object of mass 1 kg placed on the ground is 9.8 Newton. The gravitational force between the Earth and the Moon, even at large distance, is very large and is 2 into 10 raised to the power 20 Newton. Free fall. What do you mean by free fall? When a body falls from a height towards the Earth only under the influence of gravitational force, it is referred to have a free fall. The body having a free fall is called freely falling body. Imagine that vacuum is created by evacuating the air from the glass jar. Now, both the feather and the coin they will fall with the same acceleration and reach the ground at the same time. So let's talk about acceleration due to gravity or the small g. Acceleration due to gravity is defined as the uniform acceleration produced in a freely falling body due to gravitational force of the earth. Acceleration due to gravity has a value of 9.8 meter per second square. Now, how can we calculate the value of acceleration due to gravity? Everybody knows that universal law of gravitation states that the force of gravitation which is exerted by the earth on the body is equal to capital G into mass of the earth into mass of the object divided by the radius of the earth's square. And we also know that the force due to gravity is mass into G. So now equating these two equations, we get a value for small g which is equal to capital G, that is a universal constant, into mass of the earth divided by square of radius of the earth. Acceleration due to gravity on the earth is calculated as mass of the earth, radius of the earth, and the gravitational constant. All these have the fixed values, and then we can keep the values in the formula, and we arrive at a value of 9.8 meter per second square. Now, variation of acceleration due to gravity. The acceleration due to gravity decreases with altitude, it decreases with depth. Acceleration due to gravity is greater at poles as compared to the equator. Therefore, from the above equations, capital G and small m being same, and G is inversely proportional to the square of the radius. So we can say that the value of G at poles is greater than the value at the equator. Equation of vertical motion under the influence of G is, the first equation of the motion is the final velocity V is equal to initial velocity plus acceleration due to gravity into time. The second equation is height from which the body is dropped or to up to which the body is thrown up is equal to initial velocity u into the time plus half gt square. And the third equation is v square is equal to u square plus 2gh. Now the Cartesian sign for vertical motion, that is, we can take these sign conventions when we solve the numericals. The physical quantities having vertically upward motion are assigned positive values. Physical quantities having vertically downward motion are assigned negative values. Acceleration due to gravity is taken in a negative direction, and for the upward motions, g is always taken as negative. When body is dropped freely, its initial velocity is taken as 0. Thank you.